There we go. We're recording.
Yeah, fantastic. Okay, so we're live now. So I was saying I was gonna go through the usual slides, summarizing what the API is about for those of you who had never encountered it, and then I quickly move through the topic for today, which is essentially an analysis of a journal in terms of its authorship primarily. Right. So the Dimensions API, why do we have it and why it's very important? So these are the three main use cases, I would say, why people come to the API. As you probably know already, Dimensions has a very richly interlinked database. We have different content types, publications, grants, clinical trials, patents, and so on. And that in itself is a very interesting database to work with. But I think that the really interesting thing is the fact that we have so many links across this database, across these different content types. So you can really get you can really, essentially analyze the research landscape across its multiple dimensions. And I would say that the API is probably the best way to do it because the user interface allows you to slice and dice the data, allows you to essentially zoom into specific research areas or institutions or whatever you're interested in. But the perspective you get with the via the web app is always in some way limited because that's the nature of user interfaces, that's the nature of applications. They solve only certain problems well. So by using the API, by getting at the data itself, you can essentially ask any kind of question you may have. And so the number of possibilities are very much endless, I would say. So as I mentioned, the three main reasons why people come to the API are these ones. So the first one, people may have some queries that are very sophisticated, maybe queries that have a number of different spelling variations for a keyword, or a number of different keywords that you want to search for in the full text, or maybe queries where the results of one query are being used as input in a subsequent queries. For example, when you do some sort of citation analysis mapping. So doing these sort of things with the user interface can become really cumbersome. So the API, which is fundamentally a programmatic way of getting dimensions data out, is the solution in those cases. The second class of reasons why people come to the API is that they have some kind of query which is not necessarily complex, but you want to run that query over and over, maybe every week, every day, every month. Essentially because you're pulling data that would eventually go into a report or a dashboard that you want to have updated at regular intervals. So the API allows you to schedule this kind of data pulling activity in a very flexible way and essentially bring the data into your system. Finally, people come to the API because they want to get more data than what the web export functionality gives you. So with the web export functionality, you can take up to 50,000 results from a query. With the API, 50,000 is still the maximum limit for a single query. But the thing is, with the API, it's so easy to say, segment this data by year or segment it by organization or by research topic, that people normally pull hundreds of thousands of records whenever they do an analysis. Some people, they actually go over that. They get millions of records. So with the API, it's very, very easy to get very large data sets in order to carry out your research. Now, the most distinctive feature of the API, I would say, is that we created our own search language for it. It's called Dimension Search Language, DSL. The main reason why we did that is because we wanted to create something which is powerful, yet not too difficult for analysts to understand. So we know that a lot of the people who use dimensions and its data are not really developers or software engineers. There are some who are, but the vast majority of people are people who understand the research landscape very well. And so they can formulate the questions that dimensions can answer, but maybe they don't really have the time or the expertise to do complicated things with programming languages. So by building our own search language, we wanted to create something which resembles the English language and allows also specialists who are not programmers to get something out of the API quite easily. So the Dimension Search Language has a documentation website, which is open to anybody. You can just go there and have a look. It's a very, very rich language. There are so many different facets of the content types we have in Dimensions you can take advantage of. And I would say pretty much it's a one-to-one with the web application. So all the things, all the different attributes of these objects you have in the web application, you can also access via the API and more. I'll give you an example. In the web application, of course, you have information about researchers, but you cannot really search for researchers per se. It's a little bit cumbersome to do that. In the API instead, researchers is kind of a self-standing database you can dig into. So you can simply say, find me all researchers with these features, and then you can look into the researchers themselves and look at their history of affiliations and other information like that. So the API opens up essentially all the different data points available in Dimensions. A little bit of a recap, how do you access the API? There is a section in Dimensions that essentially allows you to write a query in a query form and get results back. That's the quickest way of trying things out with the API. And as you can see, the results come back in a format which is really structured. It's called JSON. It's a standard format for APIs. And by using this methodology via the Dimensions web app, you can really get a feeling for what's available in the API. You can try things out quickly, but it's not really what you would be using if you want to take full advantage of the API. So in order to do that, you either would use a third-party software that knows how to do things with the APIs. So a third-party software that has a data connector. For example, popular business intelligence or data visualization tools such as Qlik, Tableau, or even Google Sheets, they have a way of interacting with external APIs. So by using these tools, you can essentially pull this JSON data into them, and the data is automatically transformed into a table or into a visualization if you're using Tableau. The other way of interacting with the API is by using a programming language. This is probably the richest way of doing things with the API, simply because programming languages allow you to pull the data, to process it, to modify it, to do any kind of operation you may need to do in order to get to the data format, to get to the results you need. And we support the Python language primarily. We have a library for it that we maintain ourselves called Dinkfly. But there's also other libraries developed by the community of API users out there, in particular for R, which is a very popular language for statistical analysis. But of course, you can use any programming language to access the API. You don't necessarily need a library. A library makes it easier to do things like logging and logout and a few other things, as we will see, but you don't need to use a library necessarily. Right, today's focus, as I mentioned, we'll be looking at creating a journal profile. So what does that mean? These are some notebooks, some tutorials I've done together with a chief editor of a journal that I know. And so I think they kind of reflect his perspective in trying to understand, for example, who are the authors publishing in my journal? What are the top authors in a way? Where are they based? Where are they from? And the end game here is a little bit of understanding who is likely to publish again soon. So who are the people who I should reach out to? Because I know they're considering publishing, but they may not. So how can I actually get a mental model as to who are the most likely people to publish in my journal again? And related to this, the other question is, where else are my authors publishing? So how can I create a kind of, competitors map? What are the other journals where my authors publishing as well? Now, all of this analysis is broken down into 5 notebooks that you can find in the API Lab. For those of you who do not know what the API Lab is, it's essentially a collection of tutorials to show you how to use the API to solve real-world problems in general. So for creating a journal profile, we got 5 different tutorials. So as you can see from the screenshot on the right hand side. They are numbered as part 1 to part 5. I'm not going to go through all of them today. I'll try and get through the part 1 and 2, and if we have time, also part 3. And then next week, when I'll do the next session, we'll be looking at part 4 and 5. So what we'll be looking at today is essentially the first step, which is selecting a journal, putting all the publications data for that journal, and then extracting information about authors and publication, authors and affiliations. And then as a second step, essentially, we want to enrich this data set of authors and affiliations by adding some impact metrics data to this data set. So for example, the number of publications per author, the median or metric score, the median number of citations per author, and so on. And the end game of all of this is essentially getting a little bit like a spreadsheet that can be used in order to rank authors and to understand a bit better the who's who of a specific journal. So what I'm going to do now, I'm going to go to the API lab here, and I'm going to click on the journal profiling part 1 section. So for those of you who are not familiar with Jupyter Notebooks, just a quick intro about this technology. This is essentially a little bit like using a Google Doc, but being able to run code within the Google Doc. So being able to manipulate data, to pull data from an API and then changing it and visualizing it and do all the kind of operations you would do with a programming language. So the API lab contains a number of these notebooks. What you see here, this is an HTML rendering of the notebook. This is a read-only view of it. So you can use this website just to essentially take a look at what's available. In order to run it yourself, in order to customize it and do something with it, you got two options. You can either download the source code from GitHub if you have a local, if you know how to run essentially notebooks on your computer, or you can simply click on opening Collab, this button here, which essentially will take you to a cloud-based version of the notebook, which essentially relies on a technology provided by Google, which is called Collab, means collaboratory. And this is essentially a little bit like a Google document where you can add text, but you can also add code. In this case, you can add Python codes, and you can do operations such as calling the API, getting the data, modifying it, and so on. So what I have here then is a rendering, an interactive rendering of the notebook I have in the API lab. And as I mentioned in this first part of the tutorial, what we're going to do is select a journal, have a quick look at the authors and affiliations of the journal, and then do a little bit of a deep dive into the authors that do not have a researcher identifier. As you may know, in Dimensions, we disambiguate authors, and whenever we do, not just authors, also inventors or investigators for grants, so all the persons that enter the Dimensions landscape, we try and essentially give them an identifier. We try to disambiguate them. Of course, this cannot be done all the time. There's a number of reasons why that cannot be done. Maybe the names are ambiguous. Maybe we have some very old authors. There's no information about them, and many other reasons. But essentially, whenever you pull data, you're trying to understand an author's landscape. It's always very useful to essentially look at the ones that have an ID, the ones that have been disambiguated, as opposed to the ones that have not. Because many of the follow-up operations we can do with Dimensions will rely on these identifiers. So the ones that do not have an identifier, of course, will remain a little bit as a gray area in your study. So what I'll show you here is an approach of essentially extracting these researchers without an identifier and storing the data in a different format so that you can, if you like, curate the data as a second step, essentially follow up on this extra information and trying to understand how relevant it is or not relevant for your analysis. So the very first thing I'm going to do here, I'm going to log in. Let me bring this over here. Okay. So very first time you run a Collab notebook, it will always tell you this is not something you owned, something that was actually created by us, the dimensions team, and you simply click yes and continue. So what's happening in this first section here? All of this code is kind of boilerplate codes that you can simply copy paste in any in many of the analysis you may be doing. These are essentially Python libraries that are used to process the data in the rest of the notebook. As I mentioned, we have this library called imply that we created and maintained, and this simplifies the process of querying the API. In this case, we also use it to log in, and then to create an object, essentially a tool that allows to query the API. The other thing I'm doing in this case, I'm simply creating a journals profile data folder, and then a simple function where that I will use later to save the data I extract to a CSV file, and I will just stick it in that folder so that it can be reused later. As you will see, each of these tutorials will rely on data previously extracted. So by saving the data to this folder, I'll make sure I can keep this data for later. Collab, one thing I should point out is that Collab has this left panel here, which is really, really handy. It has different features. You can either see a table of contents for your notebook. If you click on the second icon there, there's a bunch of code snippets that you may want to use or look at. It can be really handy as well. And thirdly, the last icon here opens a files panel. This is a little bit like a local file system in the cloud for this notebook. So the folder I created, journals profile data, that's right there. And this is where we'll be saving the CSV files later. For some reasons, the CSV files are already there. I think that's because I ran this beforehand. Anyways, doesn't matter. Right. So the very first step here, we want to select the journal we want to look at. In this case, I select the Nature Genetics, and you can select a start year. So essentially, you want to look at papers or publications starting from a specific year. It doesn't have to be Nature Genetics. Actually, in this notebook, I put in a whole bunch of other Nature titles I was working with at the time. And of course, this is something you may want to customize at the moment you download this notebook. So we're going to run this cell here, and essentially what we're doing, we're putting all publications data for Nature Genetics from 2015 onwards. There's not very many, well, compared to other journals, which is good because it means it will take less time to run the analysis. But of course, this will work with any number of publications. All right, so now we have the publications. We're going to turn those publications into a data frame. Data frames are kind of spreadsheets for Python, and we will have a quick look at this data frame here. As you can see, together with the publications information, standard metadata, I'm also extracting things like whole metric. So the whole metric score for each of the publications, how many times the publication is being cited, and then some standard metadata like year, volume, issue, journal title, and all the information about authors and affiliation, which is nested because of course there's many authors and many affiliations for every single paper, so you don't see it here. So the next thing we want to do is essentially unpack this nested authors information. That can be done easily using a function that imply the Python library provides, which essentially says build a data frame using that nested authors information. You can do that in one single line. It's pretty straightforward. So I'm going to run it here, and that's what it looks like. So in this case, the same publications data set I had before has kind of been turned inside out in the sense that I have one row per author instead of having one row per publication. So what that means is that different rows may refer to the same publication because these are authors for linked to the same publication. But this format essentially makes it much easier to count authors, or maybe to look at how many authors have a researcher identifier or not, and so on. The other thing you can do pretty quickly is use another method of Dinkley, which is called data frame author affiliations. In this case, what I'm doing, I'm essentially creating a table where every row contains an affiliation. So the affiliations you see here in the authors table are kind of exploded. And in this case, every affiliation gets its own row. And what that means is that if the same author has more than one affiliation, like in this case, it would appear in different rows, right? And we also have the publication identifiers, which is really handy for later if we want to essentially go back from the affiliation data to the publication data. Right, so once we have the authors, affiliation, and publications, we can quickly essentially take a look at authors. And the very first thing we want to do is count how many authors we have, and then count how many have our researcher identifier. And finally, we can have a look at the unique number of authors with a research identifiers. So in this case, for Nature Genetics, there are some around 14,000 authors, non-unique, of course. So these are a little bit like authorships. In some cases, these are called. If we look at the ones that have a research identifier, there are 33,000, meaning there are some 10,000 authorships, essentially authors of a paper where Dimensions wasn't able to disambiguate the authors. Yeah, so there is no identifier in that case. And if we zoom into the ones that do have a researcher identifier, we'll see that we have around 18,000. So that's a unique number of authors that we can actually do something with in terms of further analysis. You know, with these authors with a researcher ID, we can look at the grants they have, we can look at where else they have published, and things like that, because the identifiers in Dimensions are really the main object that allows to navigate through the different links available in the Dimensions dataset. Right, so the next thing you want to do is save this dataset of researchers with an identifier, because we'll be using that in the other notebooks. And a little bit as a sidestep, we'll have a quick look at the ones that don't have an identifier. So the purpose here is trying to understand how come these guys are not actually listed in Dimensions as proper researchers. So we can see that there are, we can count them. There are around 9,000, out of which there are 4,200 that are unique. So there's quite a good degree of repetition in their names. And of course, there's many that are blank, yeah? So I can actually list them out by last name. And as you can see here, in 408 cases, there's no author. So those could be, you know, one of those funny cases where maybe the publishers send us data where the authors field is actually filled in with a consortium name. So it doesn't appear in the right place. So it's bad data to begin with. And of course, in that case, there's no author information. In many other cases, as you can see here, we see a lot of Asian names. That's also something which is not surprising, because Asian names are notoriously the most difficult ones to disambiguate, because they're widely common. So understanding, you know, the who's who with these authors is extremely difficult. So the other thing we can do here is look at patterns for these non-disambiguated authors. In this case, what I'm doing, I'm grouping them by name and surname, just to see whether some couple of names and surnames actually appear a lot. And it looks like that in some cases they do. So for example, the first result here, well, after the no first name and no last name row, is something that appears 13 different times. So despite that, it doesn't have a researcher ID, so something's going on there. And then there's a few others that appear quite frequently. So these are potentially authors that, although they will be kind of left out from the other analysis I can do using Dimensions, these are authors I still want to keep in mind if I want to understand the kind of authorship landscape for a specific journal. So what I can do with this data, what I think is really handy doing, is essentially enriching this small data set by adding another field, which is essentially a Google search URL. And the reason why we do that is because This can become a separate data set that you may want to curate manually, that you may want to follow up yourself as a second step. So by adding this extra column here, we can very quickly export the data into Google Sheets. So what happens here is that the very first time you use the Google Sheets APIs from Collab, it asks you to authenticate. So it's actually a very quick process. You just have to copy paste that identifier. Now this Collab notebook, since it's still a Google product, it knows how to talk to Google Sheets, and now essentially saving that table to a Google Sheet. So I'm going to open this up, and here we go. So that's the list of all the authors for this specific journal. They do not have a researcher ID. So as I was saying, the reason why we have a Google link in there is because in some cases, if you do not know who this person is, it becomes really handy simply to follow up on that information by searching for that person on using Google. So essentially this is, and as you can see, in many cases, you do find a person in there. So the next step would be to understand a bit better why that person doesn't have an identifier, why that paper mentioning that person doesn't have an identifier in dimensions, and possibly doing some parallel analysis to clarify and enrich the rest of the analysis with these authors without a researcher identifier. Right, so I think now we should move on to the second part of this profiling exercise. So I'm going to open this up in Collab. Again, I'm going to close down this one here just to make sure Collab doesn't complain if I have too many things running at the same time. And I will start once again by logging in to Dimensions API. Yeah. Okay. So what we want to do now is essentially take the list of researchers that we have extracted from in the previous step and enrich that list by essentially adding some information about their impact. And we can, have some simple measures of their impact in terms of number of papers, number of citations, median all metric score, and things like that. And then we're going to be visualizing very quickly some of this data to see what it looks like. So the stuff here at the beginning is essentially the same as before. I'm just loading up the imply library and other libraries that are used in the notebook. And now looking specifically at the data I want to add to my original spreadsheet. So the things we can add pretty quickly is the total number of papers per researcher, the median citation number, the all metric median number, and then finally the last publication here, because that as well will help me understand who are the researchers that published very recently with my journal. And maybe that will also tell me something in terms of who I might want to reach out to if I want to essentially get these guys to publish with me with my journal again. Right, so the very first step here, we want to reuse the data we previously saved. The thing to remember with Google Colab is that each of these windows is kind of a completely isolate cloud environment, meaning that whenever you shut it down, everything disappears. So if I open up the files section here, well, actually, in this case, you see data there because for some reasons, Collab remembered that I was running this morning. But if you run it the very first time, you would not see anything in here. So in order to reuse the data from before, it's actually pretty simple. All you want to do is follow this link, get the data that we hosted in GitHub, unpack it, and then drag the CSV files in here. So once you have the CSV files in here, the notebook will essentially work. So I preloaded the data from the previous session in here. So now it's all available. So what I'm going to do now is essentially run all the cells, because this is going to take a little bit to run. And in the meantime, I'll show you what happens. So in this case, I'm loading the publications data set. I want to have all the information about the publications and the authors one. The reason why I need publications is because the publications contain information about all metric scores, total publications counts, and so on. And I want to essentially link up the authors, the unique authors, to these metrics. So here I simply essentially from the publications and the authors, whenever there is a null value, I replace it with 0, just to make sure all the counts operations I do later do not break. From the authors, I essentially take only the authors that have a researcher identifier. So essentially, I want to focus only on the authors that are known to dimensions, and that's what it looks like. Right. So the very first thing I want to do is essentially count the number of publications they have. In this case, I'm essentially simply counting how many publications are linked to every researcher, and adding a column to my researchers table called publications, where I have the total count of publications. The second step, I want to go through essentially every researcher identifier I have in that table. And for every researcher identifier, essentially, I'm looking up in the publications data set all the publications related to him or her, and then gather all the citations counts and calculate a median, gather all the all metric counts and do a median again, and then take the last publication year. And once I have this information for every researcher, I simply attach it to my original researchers table here, so that I can have more columns representing the metrics information for that person. As you can see, this operation will take a little bit, because we have quite a few researchers, and there were a few thousand publications. So essentially, for every researcher, I'm querying the publications data sets. But fundamentally, the steps happening here are not really too complicated. As you can see, we already have the publication counts. I have essentially a nice little function here to merge together a name and surname, just because it looks better once I have the final data set. So when I have name and surname together in the table, and then for citations and all metric, I get all the values of time cited and all metric, and I calculate a mean using a pandas function, which is quite commonly used. And finally, for the last year, I take all the publications I find in my publications data set, and I take the maximum value, simply because I want to get the latest publication here. Finally, the other thing I do using this function dimensions URL, which is part of Dinkfly, I add another column containing the full dimensions URL for that researcher. So just like in the previous example, this is handy if I want to export the data and maybe add it to Google Sheets. If someone is browsing that data, you can very quickly move to dimensions and see the profile page for that researcher. And that's it. So this is now going through all the researchers. It's almost finished. We're going to give it maybe another minute. As soon as the data is available, I'm saving it in the usual journal profile data folder. And then we'll be looking at some, building some visualizations using this data. Nearly there. So I'm going to scroll down here and start talking about the visualizations already while we wait. So the first one, essentially, I'll take the top 100 researchers. Doesn't have to be the 100. You can modify that, of course, and build a simple scatter plot. Oh, here we go. Okay, so the data came through. Right. So this is my kind of enriched researcher's impact metric for this journal. I have my identifiers, total number of publications, full name together, which is really nice to look at if you want to export the data. And then the three things I added, the three metrics I added, the citations mean for each of the researchers, the old metric mean for that specific journal, the last publication here, and finally a URL, which can be really handy if I want to essentially look up this person in the Dimensions web application. Right, so now looking at the visualization. The first one is actually just give me a kind of a quick snapshot of who are the researchers that publish the most. Yeah, so I can see there's a couple of people that really stand out. In particular, one person published a lot of papers, and then the line gradually declines as expected. What you see here on the right hand side is actually the relative count of how many authors have publications in a specific range. So that's also really handy if you want to get an understanding of how frequently authors publish in this journal. But here I'm looking at the top 100. I can easily change that to be top 1000. Of course, the chart will become pretty busy. But I think the interesting aspect here is once again to look at how these groups are segmented, and it looks like they're actually pretty well. Actually, not they don't degrade very naturally, but yes. All right. Okay. Let me carry on there. Okay. So the second thing I have done here. I take again, actually that's top 100. I just change it to top 1000. Let's make it again, top 100 researchers by number of publications. So what I'm doing here, essentially representing the number of publications as bubble size and color. So once again, that's our guide that has a very high number of publications. But what I'm putting on the X and Y axis is the citations mean and the old metric mean. So this is kind of a classic way of trying to understand whether the authors who do have a lot of publications are actually cited a lot or have a very high O-metric score. And clearly this is not the case. So the people that have a very high number of citations actually do not publish as much as the people who publish a lot. And similarly with the O-metric score. So this is again another way to identify quickly some interesting patterns in terms of authorship. And finally, here I have a similar representation as the one above, where I have a bubble size representing a number of publications and all metric and citations being on the other axis, but here things are faceted by year. So this can be used in order to look at trends over the years, for example. And of course, this only scratches the surface of the kind of analysis you could do. The fundamental point here is how to enrich a researcher's data sets with some metrics that can be used to understand a bit better, who are the authors for a specific journal. Right, so that's the end of the second tutorial. I'm not too sure. Are we supposed to finish at quarter past 4, or do we have more time, Simon?
4:15, I think.
It is, yeah. So I will stop here, and then next week, I think it's interesting to look at funding. I'll just mention what happens with funding. Essentially, we're looking at the amount of funding the authors for this journal have got in the recent years, and trying to understand some patterns in terms of understanding who's likely to publish again, simply because they have some ongoing research. And then the other interesting one is looking at the competing journals analysis. So where else are these people publishing and how often, and so understanding what are the other journals that are competitors from the point of view of my journal, of course. Right, so any questions? Good. So I think we can wrap it up here. I don't see the chat.
There was one question from Rita
Oh,
about why we
yeah.
use mean and not median for the metrics.
I would say no specific reason. It could be median as well. Yeah. I think that there are possibly use cases for using both of them in this notebook. I'm just using that one. But yeah, no specific reason. I don't know, Simon, maybe something you want to add to that?
I think no specific reason is exactly the right answer.
Yeah. Someone is saying he's got crazy stats, over 1,000 publications. Jonathan, what does that refer to? I lost track. Oh, okay. Yeah, that's we may want to do a training specifically on Unitas. Yeah, that's our coronavirus denier guy.
Right,
Not really
yeah.
denier. Yeah, you know what I'm talking about.
I'd call him a skeptic.
Skeptic, exactly. Yeah, yeah. All right. Good. So thanks everybody. Enjoy the weekend. Simon, did you want to say something else?
All good. See you again next week.
Yes, lovely.
Next weekend.
Bye. Bye-bye.
Great. Thanks.